This. So 2.3 asked the question about the unit circle, and it asked you to give trig ratios, but they ask you to give trig ratios based on certain sets of angles. So they tell you that there's 4 or 5 angles that you should know. So they want you to know the trig ratios for 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360. Okay? The reason why they want you to know these ratios is it gives you the baseline for what is in between these quadrants. So if we know what my trig ratios are at 0 degrees, and if I also know what my trig ratios are at 90, I should have a good indication of what my trig ratios could be anywhere in between those two. Okay? Remember, we labeled our our three trig functions with certain roles. What did we assign? I'm going to put it down here. Sine law. The sine function. What did we assign that? What was that concept that we were going to follow? Height. What do we cosine? Overness. We don't really know if that overness exists or is a word, but we'll go with it. And tangent? The slope. So when I say height, when I ask for the height, I'm essentially asking, or sine is essentially saying is that wherever this point is, and directly below it to the x-axis, that is where the sine ratio is coming from. It's measuring from the end of the terminal arm all the way down to the x-axis. And it deals with sine. Cosine deals with overness, same thing, end of the terminal arm, all the way over to the y-axis, gives me the cos theta, or cos trig function. And finally, the slope comes from tan. Okay, so that gives you a little bit of a visual where those are coming from. Okay, are we good with that so far? Okay. So let's go back. I'd like to pick one. Well, I'll do all 4 just to give you a quick review of it. If I'm looking at an angle of 0, and I want all 3 trig functions. Sine 0, cos 0, and tan 0. When we're dealing with any of these, I'm assuming that my radius is 1. It's based off the unit circle. Okay, so we always deal with a radius of 1. That's going to help us understand what ratios are coming into play here. So sine of 0 deals with height. What's my height right now? 0. Overness. I'm over from the y-axis or the origin over to the end of the terminal arm by a factor of 1. And what is my slope? It's rise over run. My rise is 0, my over is 1. 0 divided by anything is still 0. Pretty straightforward. Questions on that? So I'm actually going to hop over. I'm going to go over to 180. I'm going to go over to 180 because is there really much of a difference between... Oh, where's the negative coming into play? Which one? Cosine becomes -1. Why? I'm on the negative side. Does anything happen different with sine or tan? No. No different. Okay? What about at 90 degrees? What happens to sine 90, cos 90, and tan 90? 1, 0 what?
1, 0, 0.
It is 1, 0. Sine is 1 because my height is now 1. The cosine is 0. The overness is 0. Why is tangent not 0? straight up. So we know that a horizontal line is a slope of 0. So I can't have 0 represented two ways. Think about when think about movement. If I'm standing completely still, my slope or rate is 0. As I start to speed up, my rate is going to increase. So I go from walking to running to sprinting to driving a car to flying a plane to on a rocket ship, spaceship, to the point where I'm completely vertical. Okay? Essentially, I'm going so fast that I can't measure it, so it's undefined. So I can put NA, undefined, no, it does not exist, doesn't matter. When you put into that into your calculator, Lucas, you had actually said it's rise over run. What is my rise on this line right now? My rise is 1, but my run, my overness is 0. Anything divided by 0 is a non-real number, it doesn't exist. You can't divide a number by 0. That's why it becomes an error. That make sense? So likewise, if I go down to 270, and I write down the same things, what should be different between 270 and 90? Everything should stay the same except wherever I had a 1 before is now negative 1. So sine now becomes negative 1, cosine becomes 0, and my slope is still not applicable. It's just we were going really, really high up before, now we're going really, really far down now. Okay? That's essentially what 2.3 was asking you. What they're eventually, the plan is that we should have, the reason why we show you this, and the outcome asks, be able to do this without a calculator, is that they want you to recognize these patterns. So a comparable question would look like this. You might have something that says, determine the ratio for tan of 360. You know that the ratio for 360 is the exact same as 0. So that means my slope would be 0. That would be a comparable question. You don't have to do any math. Could you solve this with a calculator? Absolutely, but it's kind of like your times tables. Eventually you just have to know them. Okay? Eventually we want you to know a certain amount of angles and what their trig ratios are. Does that make sense? So what's going to end up happening is you're going to have a data bank of angles that you're going to know all the trig functions are. By the end of the day, you should know 0, 90, 180, 270 before 360, 270, and 360. Those should already be done because that's essentially what we just did, right? You should know sine, cos, and tan for each one of those angles. Okay? Make sense? You shouldn't have to use your calculator. You can. If I need to double check or triple check, what did I say, 360? Gives me 0. You can check them. But again, if I know them already, which is quicker? If I know them in my head, or if I have to go back to my calculator every single time? Because when you come to when I go to an assessment, or if I'm doing an assignment, I don't want to have to waste my time using those small answers or small questions when I could be dedicating my time to the more complex questions. Okay. Today, my plan is to give you 3 more angles that I want you to be able to do the same thing. Okay. 30, 45, and 60 are what's called special angles with regards to the unit circle. We're going to unpack those today. Okay? You'll be able to, by the end of this, do the same thing as you can with 0, 90, 180, 270, 360. You're going to be able to break down, boom, where these are coming from. Alright? We're going to do that right now, unless there's any other questions from 2.1, 2.2, 2.3, or 2.4. All good? So the expectation is those notes should be banging. They should be ready to roll. Alright? Okay, so let's start talking about what sine 60 looks like. I'm gonna actually draw it again because the note package that I created does not give me a whole lot of room. So let's say I've got an angle, and and I'm telling you that this angle here is 60. We're still using the idea of a unit circle, so what number could I use, or do I know with, what kind of information do I know with regards to the unit circle when I have an angle included of sine, or of 60? Do I know any specific number or any information? The radius or my terminal arm is absolutely 1. Can I create a right angle triangle from this? Absolutely. Okay. Now, I'm going to show you this one way. There is another way to solve it, but it kind of gets a little hairy on how we solve it. So I'm going to find my adjacent side first. Everybody sees this right angle triangle. Then if I wanted to find these two missing sides, because in order for me to build a trig ratio, I need to know all three sides, correct? Okay. I'm going to find the adjacent first. I'm going to find x first. What information do I have? I have an angle and I have the hypotenuse. So if I have the hypotenuse and I need to find the adjacent, what trig law am I going to use? Anybody remember that from grade 10? Cosine. I'm going to use cos 60 is equal to adjacent, which we'll leave it as x, over the hypotenuse, which is 1. How do I get x by itself here? Don't you just switch? I times it by 1, but does it really, it doesn't really make a difference right now. It's just because it's over 1. If it was 2, then it might. Okay? So I can multiply that by 1, multiply it by 1. So now I'm just going to have cosine of 60 is equal to x. Alright, well, just like I said in the outcome before where you say without the use of technology, that's okay. I can still use technology to understand it first, and then I can start incorporating the idea, I can start remembering those after. If I put cosine of 60 in, what do I get? 0.5. What's the issue with writing down 0.5? What did I get you guys to do with 2.1 when you had to find the terminal arm? Keep it as a radical. And why did I say keep it as a square root or a radical?
Because you don't want to deal with it.
I don't want to deal with decimals, right? So we don't like dealing with decimals, we like dealing with exact values. 0.5 is a terminating decimal. I respect that. However, is there a way that I can write that as an exact value? There's another way to write 0.5. 1 over 2. Alright. So far in our triangle, if I recreate it, with 60, with 90, this side is 1. I've now figured out 1/2. Can I find my third side? I want all your hands to be raised that you can tell me what formula I would use to find the third side. I want your hand up. Because I want to make sure people are thinking and not just duping. Keegan Timmons, what is it?
A squared plus b squared equals c squared.
Hell yeah it is. Well done. A squared plus b squared equals c squared. In this case, 1/2 squared plus b squared will equal 1 squared. When I'm squaring a fraction, I have to put that exponent into both terms. So 1 squared, or 1 times 1 is? 2 times 2? B squared, and then 1 squared is just 1. Now, how do I get b squared? Actually, what I'll do, instead of writing it b, what's the variable that I labeled it as? Y. So we'll go y squared to keep it consistent. Okay? How do I get y by itself? I have to do something first. I have to isolate it, or I could subtract 1/4. Now, I have $1. I take away 1/4. How many quarters do I have left? 3 quarters. Y squared is equal to 3 over 4. How do I get rid of the square? I have to square root it. When I'm square rooting a fraction, I actually have to square root both terms. Remember that time you said that what do I ask you to do? Keep a decimal or keep the radical? What do we do? Keep the radical. Square root of... Sorry?
How'd you get 34?
If I have $1, take away a quarter, I have 3/4. With square root of 3, does that become a perfect number or no? Perfect square? Yes or no? Is it going to give me a decimal if I work it out? So I'm going to leave it as root 3. Well, what about square root of 4? That breaks down to 2. So now I know my third side. So if I go back to my triangle, this now becomes root 3 over 2. Does that math make sense so far? Pretty straightforward? So if I go back to this information, what's that? I now know that this is 1, this side is 3 over 2, and this side is 1/2. Right? We just did the math to support that. So now, and what I'm actually going to do, I'm going to use tan of 60 as well. For some reason, I had a brain fart. I didn't want to show you tan, but I valued it. You might as well keep consistent, right? Sine measures what?
Height.
Height. What's my height?
3 over
Root 3 over 2. Cosine is overness. 1/2. Tan of 60, I have to do rise over run. What's my rise? Root 3 over 2 divided by the run, which is 1/2. Yeah, that doesn't look like a very nice formula, but what number could I multiply everything by to make this go away? Good. I've got two denominators that are multiplied or divided by 2. Sorry, two denominators that are 2. So if I just multiply everything by 2, I bet you it'll go away. Before I do that, if I have x and I multiply it by 2, what does it become? 2x. So if I have root 3 and I multiply it by 2, it uses the same concept. What would be my answer? 2 root 3. Because these two terms are not identical, I can't blend them into one magic variable number concept. Okay? So I write it as 2x. Root 3 is a radical. 2 is just a standard constant. Constant and a radical they don't make a radical number love child, okay? They have to be written side by side. 2 root 3. The only way, and we'll actually talk about this when we talk about radicals, the only way you can multiply a root 3 together is if this was root 3 times root 2. Then you can multiply inside to make root 6. So for now, what does this top term look like? 2 root 3. No, it's just over 2. Remember, when I multiply by 2, I just multiply by the numerator. Because my denominator is 1. 1 times 2. Make sense? 2 times 1 is? 2 divided by 2 is? 1. So my answer, 2 root 3 over 2. Can I simplify that at all? If I had 2x divided by 2, just going to become root 3. These cancel. So my slope now becomes root 3. You now know the trig ratios in exact form, so when you see a 60-degree triangle. Make sense? Is everybody following that so far? Okay. So my next question. What is the third angle on this triangle?
160 minus 90 minus 60.
Try that again.
I mean 180.
this is 90, so I'm trying to figure out what this angle is. 30. Interesting.
Because you never try to do something.
Oh, crap. What happens when I now deal with the sine law, or just not sine law, the trig functions or the trig ratios, for when my angle is 30 degrees? Do I really have to do any amount of math right now? Because if I use this concept, I've got 30, I know this is 90, this has to be 60. Do I not know the side lengths already? I totally do. What's this one? The hypotenuse is 1. The side opposite of 60 degrees was what length? Root 3 over 2. What was the side length opposite 30? Was 1/2. Without having to do any math, what's my height?
1.
Nope.
1/2.
1/2. What's my overness? 3 over 2. What have I done?
Flipped it.
Just switched it. Essentially what's happening is my triangle has turned so that now instead of using the 60 degree, I'm using the 30 degree as my reference point or my reference angle. All that does is switch the terms of what I'm dealing with regards to sine and cosine. The last thing, the other one that's a little tricky, is tan 30. What I'll do is I'll actually move that so it's consistent. Okay? That's still rise over run. So my rise this time is 1/2. My run is root 3 over 2. We should all know how to deal with that though. What do I multiply this by? I'm still going to multiply by 2. This combines to give me 1. This combines to give me 2 root 3 over 2, which cancels down to 1 over root 3. Now, that becomes my slope. So the question came up yesterday. Actually, it was Brianna McCachran's calculator. She has a very handy calculator that actually, when she posts, she writes tan 30, the radical comes up as an exact value. So that's pretty cool. But what she said she was having a struggle with is that when she put tan of 30 in, she would get something that looked like this. Okay? Somewhere along the line, someone said, you can't have a radical on the denominator. Okay? It's not a thing, it doesn't exist. You have to be able to keep your radical terms above in the numerator. Okay? I'm impartial. I'm not judgmental to radicals. If they want to be on the denominator, they can be on the denominator. But here's how this number equals this term. If I'm given 1 over root 3, and I want to get rid of that radical that's on the bottom, I need to do what's called rationalizing the denominator. I have to multiply it by 1. How many different ways is there to multiply by 1? There's 1. I can multiply by 1. Is there another way I can multiply by 1? What about 1 over 1? Is that still 1? What about 2 over 2? That's still 1? What's another one? Okay, another one? So then having said that, is root 3 over root 3 still 1? So am I doing anything different? I'm just multiplying by 1. It's not going to change my answer, right? What happens when I multiply two fractions? I have to, how do I multiply two fractions? No, can't cross. I'm going to, numerator gets multiplied by the numerator, denominator by the denominator. 1 times root 3 is equal to root 3. Remember how I said root 2 times root 3 gives me root 6? So what do these two multiply again? Root 9. What is the square root of 9? give you the same answer. Okay, it's the exact same thing. In the math world, this term is more accepted than this term. Okay? You are not going to lose marks from me if you write it like this. Understand that this is the expectation, that you need to know how to rationalize the denominator. But I'm not going to say, well, the thing is, just be aware of it, because when it comes to diploma time, when you're in your grade 12 year, they're probably going to expect you to know how to convert that to a radical on the numerator. Okay? Questions on that? Is it okay so far? So now we've added 30, 60. What's the last one we need to do? 45. So if I go down to 45, I'm going to build my coordinate grid. I'm going to build my angle at 45. I know that this is a radius of 1. And I can build my right angle triangle. Question, what's this third angle?
45.
Okay, interesting. What kind of a triangle does this become? Put your hand up, don't yell it out. When you know it, put your hand up. If you are not sure, there is something over here that will help you say what type of a triangle this is. If you are not sure, ask a friend. What type of a triangle is this term? Let's see.
It wasn't working for me earlier.
Mitchell Gorman, what is it? It's an isosceles triangle. Because I have two side angles that are the same, 45 and 45, that means these sides here are going to be the same. So if I'm drawing this out, I'm saying that this side is going to be x. Where else am I going to see, what variable can I use for this term? I would use x because they have to be the same side length. Excellent. Can I solve for that side length now without having to do any trigonometry? What's my equation that I use when I have two sides and I'm looking for a third? A squared plus b squared equals c squared. Okay, I know for sure c squared is 1 squared, right? And we've converted this side to be x squared, and we've converted this side to be x squared. Is there a way I can simplify those together? 2x squared. And then 1 squared is just 1. Can I solve for x here? Sure I can. If I divide this by 2, divide this by 2, I have x squared equals 1/2. And if I square root it, I get x equals, what's the square root of 1? Over root 2 is not a perfect square, so I write it as root 2. If I said rationalize the denominator and write it as a proper radical form, 1 over root 2, what would I have to multiply this by? Root 2 over root 2. That gives me root 2 over root 4, which is the square root of 4 is 2. So, what does that tell me my two side lengths are? I will move it back down, Christian, sorry. I've got root 2 over 2, and I've got root 2 over 2, or 1 over root 2. Okay? Is that good enough there, Christian?
Yeah.
Are we good with that so far? Pretty straightforward. Nice, easy way to find my height and my length. Rationalize the denominator. So again, like I said, the question, some of the issues is that this is a legit answer in my world. I believe it. I don't see anything wrong with it. Some math worlds, some places prefer if you didn't write it this way and actually wrote it like that. I'm timesing by 1. How I times by 1 is completely up to me. The simple rule is, whatever this radical is, times everything by it. So if this was root 5, I would have root 5 over root 5. That make sense? When we go into radical expressions and equations, we'll do a lot of that, okay?
And you just got rid of the.
Essentially what happens, what's 2 times 2?
2 times 2 is 4.
And the square root of 4 is 2. Essentially when you multiply a square root by itself, you're going to get the number, the radicand, the number that's inside the radical alone. Okay? Good with that. So, having said that, we should be able to figure out my sine ratio, my cos ratio, and my tan ratio. What was my height in this triangle? Root 2 over 2. What is my overness of this triangle? Root 2 over 2. Now, how do I find my tan 45? I have to find the slope. Rise over run. So, if I go root 2 over 2 divided by root 2 over 2, what's that concept called that if you multiply, if you take a number and divide it by itself, it's 1. I don't even have to show you any math to show that this is equal to 1. So what's my slope?
1.
Again, to make sure that I'm right, and actually I want to, the reason, so here's the other thing. So I'm making these as special angle triangles, yes? We've focused on 30, 45, and 60. The reason why I'm sharing this information with you and why, I'm sure some of you are thinking right now, Mr. D, I can just put these in my calculator, I'm going to get a number. Okay, sure. If I put sine of 45 in, I get a really crappy decimal. What do we say about decimals? Do we like them or we hate them?
Oh no.
Not a big fan of them. Okay, I would prefer, in this format, exact values. Yes? Yeah. So, my calculator is not good enough to tell me how to convert 7071 into an exact value. However, I have built, have I lost anybody with the math that I've done so far to come up to root 2 over 2? No? So what if I put that into my calculator? Root 2 divided by 2. I get the exact same ratio.
How do you
This calculator sucks, so I have to put the number first and then hit square root. Your calculators, the TI, the graphing calculators, you can write it all out. Okay? But just make sure when you're writing it out, it'll go square root, and then if you go 2 divided by 2, it'll just say the square root of 1. Okay? Does that make sense? So we've done that for all of them. So we had another one, root 3 over 2. So if I go back, sine of 60. 0.8660. If I take the square root of 3 and divide that by 2, I will get 0.8660. The exact same ratio. It just is a way for you guys and girls to understand that I can manipulate those heights and those lengths using exact values. Okay? Get used to that because it's not going to be the nicest thing. We've all agreed. I'm not going to be looking at ratios that are decimals. Okay? I'm going to, especially in the examples that you'll see, they will have a very similar reference, if not exact reference angle, to the bank of angles that we've dealt with. Okay? You will see angles that look very similar to these concepts. That make sense? Questions on that? So we don't need to do the summaries, we just talked about that. But here's my examples. Ooh. Always happens. That's fine. Okay. So, what I want you to do, what I want you guys to do, is we have all these different angles now. The first thing I would ask you is to figure out what this reference angle is. What this one, this one, this one, this one, this one. Figure out each of your reference angles. And when you know the reference angle, could you not go back to your notes and figure out what the trig ratio is that you're dealing with? For example, 135, what is that reference angle? 135 is in quadrant 2. If I look back at my equations over there, to find the reference angle, I take 180 and minus the angle. So 180 minus 135 gives me a reference angle of 45. What do I know about the sine of 45? What was the trig law? Or the trig ratio? Square root of 2 over 2. That's all you're doing. Go. Give them a try. I'm going to break up this video.